Okay, today we're moving on to section 1.5. Again, we're in quadratic functions, but what we're doing today with our parabolas is your goal is I can relate the equation of a parabola to its graph, and I know what part of the equation moves the parabola around the grid. So we're going to be changing the equation, and when we change it, I'm going to, or you're going to be able to know what that means as far as where the parabola moves on a grid. So another thing to point out, test coming up shortly, people, not too much left in this unit. Okay, translations of parabolas. So in simple terms, a translation just means a slide around the grid without changing its shape or orientation. So orientation means if it opens up, it's still going to open up. So for instance, if I take, and let's just see what we have here. Okay, so I'm going to take this and say, for instance, this is my parabola. What it means when I go to slide it, I literally slide it. I move it right or left, up or down, but I'm not flipping it over. So that's all it means is I'm taking the parabola and I'm just moving it. So I'm cloning it. So I'm just moving it. That's all it means. So we need to know where in the equation tells us which way to move it, and that's what we're going to be looking at. So in general, the equation for transforming a parabola is the following. Okay, we have our x, it's been opened up and we've thrown a number in with it and then squared it, and then we've added something to the equation. So for instance, if I have something that is x plus 3 squared, what that tells me is my h value is -3. Now you're saying, why is it -3? It says plus 3. Yes, but if you notice in this equation, it says x minus h squared. So it's the opposite sign of what you're seeing in the bracket. Okay, so we're going to use the graphing calculator to complete the following thoughts. Okay, so the first thing we're going to do is we're going to be changing the k. So what do you think happens when we change the k? Well, we're going to bring up the graphing calculator again. As I said, we spend a lot of time with that. And I'm just going to clear its memory. And we're going to take our parabola and say, for instance, we're starting with our normal one. Okay, so there's our normal parabola. So what happens if I add something? Okay, what happens if I have, if I put a negative number in for the k? So say, for instance, we put a -3. So if I have x squared minus 3, what do you think is going to happen? Well, it actually moved the parabola down. So what do you think would happen if I put a positive value in for k? Well, let's try it. So let's have our x squared again, and this time we have a positive 3. Well, it moved the parabola up. So what happens if I put 0 in for our parabola? Okay, so this time I'm going to clear these other ones so we can see. So here's our x squared that we started with. So if I put a 0 in, x squared plus 0, notice nothing happens. So it keeps it in place. So let's just add that now to our note. So when we changed the k, okay, so that was after the squared part. If we change the k and we have a negative, the parabola is shifted down. If we put a positive value in for k, the parabola is shifted up. And if we put 0, the parabola is not shifted up or down. It just stays in the same place. Okay, makes sense. Now this time what we're going to do is we're going to change our values for h. First of all, we're going to put negative values in for our h. Okay, so what we're talking about is negative values means that we're going to put x plus 3 in, for instance, okay, into that equation. So let's find out what happens. Oop, shut off on me. Okay, so I'm going to keep that normal one there. So this time I'm going to put a bracket x plus 3, close my bracket, I'm going to square it. Okay, you can see the value that I replaced the h with was a negative 3. Notice what happens. Here was our x squared, and it has moved it to the left. Okay, so if I want to move it to the left, I put a negative number in. Okay, so I wonder if I want to move it right, if I put a positive in. Amazingly, that's what it looked like. Now, what happens if I put 0 in? Okay, so this time I'm going to change that to 0. Notice I don't see any change at all. So what's happening here is when I put a negative number in, so in other words, when the bracket becomes positive, it moves the left to the left. So it looks like this when I put a negative number in. So it's the opposite of what you would think when you just look at the bracket. When I put a positive in, it moves to the right and it looks like this. Okay, so it kind of looks backwards. So you have to really be careful with that because that's really one of the trickiest things. Okay, and when we put a 0 in, it doesn't move left or right. So not too bad. The only tricky part I would say would be when we change the h. Okay, because the bracket looks different. Okay, but we have to remember that if I want to have a positive number in the bracket, I'm actually putting a negative number in. All right, so let's go on to the next part of the lesson. And this time, it's asking us to give the h and k value for each parabola. Now, what I'm going to do is I'm just going to write that h and k version down. So y equals bracket x minus h squared plus k, just so that we remember what it was. Okay, so when I look here, this is a positive, so that means a negative number had to go in. Okay, so I know that when I do this, that h is negative 3, so that means I went left 3 spaces. And I can see that my k is a positive 5, and that just means that it moves up 5 spaces. So just be careful with that again with that bracket. Okay, so next one. I have a negative 6 in here, so that means that I must have put a positive number in for h. So that means h is positive 6, which means I've moved it to the right 6 spaces. And my k is a negative 2, which means I've moved it down 2 spaces. Now, when I look at the next one, I have x squared plus 7. Notice this time I don't have a bracket with my squared part, so that means that my h is 0, which means I'm not moving it up or down. And my k is positive 7, which means I am moving my parabola up 7 spaces. The next one, again, my bracket's been open, so I have an h value other than 0, and this time it has to be a positive 7 because notice that the equation here is a negative, which means I must have put a positive in order to remain negative. So that means I've put it right 7 spaces. And notice nothing's been added or subtracted, so that means my k value is 0. All right, so example 2, what are h and k in this following equation? Well, opposite sign here, so that means my h has to be negative 2, and I have a negative 5, so that means my k has to equal negative 5. Now the vertex of y equals x squared was 0, 0. Where does it move under the following transformation? So normally I had, before I did any translations, before I slid anything, this was x squared. Okay, I had nothing added or subtracted. So what happens to this? Well, it means that my vertex has now changed. My vertex now has become the negative 2, negative 5. So the vertex is always the value of h and k. So very important. So you might want to put a star beside that. Very important. Okay, so now what we want to do is we want to be able to graph. Okay, so step one when we're graphing is we're always going to start with the vertex. So graph the vertex, which is given by h equals k. Okay, so for A, for instance, we're doing this one here. So that means I would put over 2, down 5. 1, 2, 3, 4, 5. Okay, so there's my vertex. And then what I need to do, it's actually very easy. I'm going to graph each point from the vertex according to this chart. And the chart is what we've been working with all along every time that we did this. So over 1, up 1 squared, over 2, up 2 squared, over 3, up 3 squared. I don't care where the vertex starts. I just need to have where it starts and then follow this step pattern. Okay, so some people call it a step pattern. So I'm going to go from the vertex over 1, up 1, back to the vertex, over 2, up 2 squared, over 3, up 9. So I'm at 5, so 6, 7, 8, 9. Okay, so there's quite a few points there. And to get the other ones, I just do the other side the same way. And it's a matter of then joining them with a smooth curve. Mine's not real smooth, but it's the best I can do with my mouse. And I have to put arrows because it does continue forever. Okay, so that step pattern again is also something that you should know. Okay, so a couple different things. A vertex is always HK, and the step pattern, if there's no A value in front of our bracket or in front of our x squared, is always this. Okay, have some mathematical pleasure.